I'm K. Prakash, working as Assistant Professor in the Department of Mechanical Engineering, Business Knowledge of Technology. In the lecture series, we have discussed about the steam power cycles. So, in the steam power cycles, we have discussed about the ideal Rankine cycle. So, today we are going to discuss about the Rankine cycle with reheat cycle. Okay. So, before going to the topic, let's recall. Okay. So, let us recall what is meant by Rankine cycle. So, here in the Rankine cycle, we have discussed in the previous lecture series. Here we are using some modification. Okay, in the Rankine cycle, we have used boilers, we have used turbines, we have used condenser, we have used the pump to do the heat supply and the convert into work. But here we are having small exception. We are using two types of pumps and turbines. Okay. So now, before going to the topic, we will have some empathy, because the first stage in the design thing is empathy. So here, the existing cycles, okay, the existing Rankine cycles, because of the dryness fraction and because of the wet steam, the blades are getting damaged in the turbines. So this is a major problem when you are using in the Rankine cycles. And then here, the waste heat which is rejected and the conversion of work done, thermal efficiency is very low. Okay. So corrosions, thermal efficiency, and here the conversion of the dry steam and wet steam takes an important role. Okay. So the higher dryness fraction, so we are having the wet steam which makes an important role in the corrosion of these blades. So these are all some existing empathy problems by using this Rankine cycle. So now, how to empathize this? Okay, so we are defining with the reheat cycle. Okay, so in the reheat cycle, we are defining the problem that the dryness fraction has to be increased. That is, the quality of the steam has to be increased. Okay, so here there is a boiler, here there is a pump, we are using a condenser and then turbine. Here the same process takes place, but what we are going to define is we are going to increase the thermal efficiency and the quality of the steam. So now let's have the idea for this. What is the idea behind this here is how to increase the dryness fraction. Okay. So here generally we will start from here. So the working fluid, when it comes from the pump, it is pressure increased and it is supplied to the boiler. Okay. So from the boiler, superheated steam is produced. This superheated steam comes to the high pressure turbine. So in the high pressure turbine, work is extracted. Okay. So all the heat which is present in the steam cannot be extracted into work. So some amount of the heat is converted and the superheated steam becomes dry steam. So here in the boiler, what happens is after burning, enormous amount of heat is wasted to the atmosphere. So this waste heat which is going outside is reused to heat this dry steam. So again this dry steam is heated, becomes some superheated steam. Again it goes and runs the low pressure turbine, and then the condensate becomes water and comes to the pump. Okay. So what is the advantage of this? What is the comparison of the Rankine cycle and the reheat cycle? Okay. So here, by using this temperature and entropy diagram, let us see here. You can see the increase in the superheated steam. So this area, place the superheated steam area. Here this is the dry steam and wet steam area, and this is liquid. So here more amount of work is extracted in case of Rankine cycle with reheat, because the waste heat is going outside is utilized to reheat the steam, so that the work output is increased. So how the process takes place here is, so the 1 to 2 is an isentropic process. Here water is pumped, okay, and then 2 to 3. Here 2 to 3. What we are doing here is we are heating the water at constant pressure process, okay. And next, when it comes to this turbine, first there is a high pressure turbine and then a low pressure turbine. Here what happens is isentropic expansion takes place in the turbines, and then In the low pressure turbine also same constant pressure heat addition and then expansion takes place. So here, so expansion process takes place in isentropic and constant pressure heat addition and rejection takes place. Now let's have some assessment. These questions are based on the thermal power plant process. So, specifically the steam quality to maintain the turbine exhaust. What is the steam quality to be maintained? Okay, if the percentage is very low or high, we are going to see the corrosion part. Okay, so that what will be the percentage? So you can discuss these answers and you can give your answers in your comments. And here the working principle is, so mainly the water is converted into superheated steam. So again the turbine work is taken as obtained in the high pressure turbine and also in the low pressure turbine. So two in places work is extracted. So this plays an important role in the expansion of the steam and then work is improved so that thermal efficiency is increased. So this is how the working principle. So with this we will conclude this lecture series. We will discuss in the next lecture series about this reheat cycle. Thank you.